Hi all, welcome to lesson 9, inverse of function. So I want you to pause the video and try the warm-up. So the warm-up here says determine if each of the following is one-to-one function. So let's review what one-to-one function is. What is a function? A function is when x values do not repeat, right? X values do not repeat. So now what is one-to-one function? Y values do not repeat. So now for the warm-up, let's determine whether these three are functions or not. Let's sketch them. If I were to sketch them, how do I determine from a graph whether a given graph is a function? First of all, we do the vertical line test. If I draw a vertical line, it touches the graph only once, so I know it is a function. But how do I check for one-to-one? For that, I need to do a horizontal line test. That line's also touching. No matter where I draw that line, it's touching the graph only once. So it passes both the vertical line test and the horizontal line test, so it is a one-to-one function. So it is y equals x cubed. So look at this, x squared, sorry. So y equals x squared is a parabola with a vertex at the origin, right? If I draw my vertical line to check whether it's a function or not, it is a function. No matter where I draw that vertical line, it is a function, right? So now let's check whether it's one-to-one. For that, I'm going to draw a horizontal line. Oh, look here. My horizontal line touches the graph at two places. So it is a function. Yes, a function, but not one-to-one, because it does not pass the horizontal line test. Right? You can actually look at the table and talk about the same reasoning for it, or you can do it graphically. Either or is fine. Now the next one, C. It says, again, draw the vertical lines. So if I draw the vertical line, it is a function no matter where I draw them, right? Now let's draw the horizontal lines. Is it one-to-one? Yes, it is one-to-one, because it is touching the graph only once. So yes, one-to-one, and this is also yes, one-to-one. The graph of an inverse function. Graphically, the x and y values for every point of a function and its inverse are switched. What does that mean? Switch here. I gave an example right here. If I had in my original function a point 3,4, it will switch to 4,3. When we're talking about switched, we're talking about the x coordinate becomes the y and the y becomes the x. The graph of a function and its inverse are mirror images about the line y equals x. And I gave you a few examples here. So this dotted line is actually y equals x. And look at this. These are my two functions. So this is f of x, and it has a 0.35. And its inverse, which is the f, and this is the notation for inverse. And you read it as f inverse of x. So that's how you read it, right? And it has the 0.53 on it. So this is what I wanted to talk about, that the points are switched. Again, this is the line y equals x, and these two graphs are switched. Oh, it says there. And again, a parabola. The original is a function. This is the blue ones are the original function, and the red one, the dotted one, are the reflection or the inverse of the. Definition of an inverse. A function f has an inverse function g if and only if f of g of x equals x and g of f of x equals x. So this is actually compositions. That's what we've done in the past lesson, right? You can actually find the inverse if you do the composition and you get both of them equals x, then you know that the two functions are inverses of each other. So the domain of f is the range of g, and the range of f is the domain of g. If you were to talk in terms of x and y, this is what I meant initially when I said the points are switched. Like the x of f is the y of g, and the y of f is the x. Example 1. Find the inverse of f of x and then verify that f inverse of x is equal to f inverse of f of x. So remember, the notation for inverse is this. Please don't read it as f to the negative 1. That will be wrong. This is f inverse of x. Okay, so first they want us to find the inverse. So going back to how do we find inverses? So I'm going to do it over here. So the first thing to do is rewrite the function with y. And since inverses, we are switching the domain and range. So switch the x and y. So x is equal to square root of 2y minus 3. And solve for y. So can I say that set your equation to y, set to y, switch x and y, and solve for y. Okay, so set, switch, solve. That's how I sometimes say it. So if you can remember that, that'll be easy to do what you're doing. And now I want to solve for y. How do I undo a square root? I will take the square, right? What I do on one side, I do the same on the other. So it is x squared. The square and the square root cancel out. I'm left with 2y minus 3. Add 3 on both sides. Divide by 2. So I get, and that's f inverse of x, equals x squared plus 3 over 2, right? So that is my inverse. This is my inverse. So now we are going to do the second part of this question that says verify. So what are we trying to verify? We're trying to prove that this part is equal to this part. So I'm going to start with the first one, f of f inverse of x. So I'm going to write that here. You always, whenever you're working with compositions, please start with the function on the right. Oops. So this is f of f inverse of x, right? In place of f inverse of x, can I not substitute this x squared plus 3? So I'm going to rewrite this as f of x squared plus 3, right, over 2. Now go to your f function, and wherever you see x, in place of x, you're going to substitute what? X squared plus 3. So let's do that. So this would be square root. I don't change anything. In place of 2, I'm not doing anything. Only in place of x, I'm going to write x squared plus 3 over 2 minus 3. And all you need to do is simplify. When you're simplifying it, it is PEMDAS. So get rid of your parentheses first. The 2's cancel out. What are you left with? F of x squared plus 3 over 2 is equal to, this is what? X squared square root of x squared plus 3 minus 3. Don't the 3's cancel out, and you're left with square root of x squared, which is what? Just x. So can I rewrite this as f of f inverse of x is just x, right? So now for the second part also, if I get the same value x, then I know these two are inverses, right? So that's what we're trying to do. So let's get started with that. So I'm going to start with f inverse of f of x. So in place of, again, oops, I have an extra parenthesis there. In place of f of x, I am going to substitute what? My f of x function, right? Which is this, square root of 2x. So I'm going to rewrite it f inverse of square root of 2x minus 3. So go to your f inverse function, and wherever you see x, you're going to substitute it with square root of 2x plus 3. So, oops, it skipped here. So I have square root of 2x plus 3, right, squared. That's what I'm writing. plus 3. Oops, I can't write here. I'm going to erase this. I'm going to write it a little tinier. So I'm going to write my outside function. I'm going to substitute f of x with its original function, square root of 2x minus 3. And I'm going to go to my inverse function, and wherever I see x, I am going to write square root of 2x minus 3 squared plus 3 over 2. The square, this is all over. The square and the square root cancel out. So what are you left with? F inverse of 2x minus 3 equals 2x minus 3 plus 3 over 2. The 3's cancel out. You're left with 2x over 2, and the 2's also cancel out, right? You could cancel that then, and you're left with what? F inverse of f of x is just x. So what can we say? That they both got the same x, they both equal to x, so therefore we use 3 dots to write therefore f inverse of x is equal to f inverse of f of x. So you must conclude that, because that's what you're verifying. That's actually your proof. That's how you prove whether if something is an inverse. Verify means proving. Right? So this is your proof. This is how you prove it. It is a little bit more work. If you feel this is too less space for you guys, you can actually take a blank sheet of paper and do it there, but you must show all of this. So I want you to actually try practice problems 1 and 2. I hope you tried numbers 1 and 2. These are the answers, and first I found the inverse and then I verified it also, right? So I want to do actually number 4 with you guys. So I'm going to zoom in right here. So again, the first thing to do is find the inverse. Anytime you find the inverse, you must set it equal to y if it's in function notation. So I'm going to first set it equal to y. So y is equal to 2 over 3 x plus 4. Switch. So it'll be x equals 2 over 3 y plus 4. I want to solve for y. So it's x minus 4 equals 2 over 3y, right? And what do you do? Now you want to get rid of something, a coefficient in front of it, right? How do you undo fractions? You multiply by the reciprocal. So this would be 3 over 2. So on the other side also you're going to multiply by 3 over 2. But please make sure that, remember, to distribute the 3 over 2, put that in parentheses if there's a binomial. Like x minus 4, there were 2 terms, so I put parentheses around them. And I'm going to distribute it. So this would be 3x over 2. And what's 3/4 times? This would be negative times 4. 4 is what? 3 times 4 is 12. And 12 divided by 2 is just 6. So it's going to be, 6 equals, this cancels out. It's actually 1. So that's what your answer is. Or you can choose to write it as 3x minus 12 over 2 equals y. Either or is right. So let's use our notation. That's your f inverse of x. Always write your final answer as an inverse. So I'm just going to rewrite it like this. Let's say we put it over the whole fraction. Now we want to do f of f inverse of x, right? So I'm just going to draw a line here so that we know that's a division. So I'm going to rewrite it, what I'm finding, f of f inverse of x, right? So what I'm trying to do is I'm going to just substitute the inside with what I found. So I'm going to rewrite it as f of f inverse of x was what? 3x minus 12 over 2. It won't be right or wrong if you used either 3x minus 12 over 2 or 3x over 2 minus 6. They're both right. One is simplified, the other one wasn't. So now I'm going to go to my f function, and wherever I see x, I'm going to substitute that with 3x minus 12 over 2. So let's do that. That's going to be equal to 2 over 3, and here I'm going to substitute. Instead of x, I'm going to write 3x minus 12 over 2, right? Plus 4. So here, let's factor this out. Simplify this, not factor it. So the 2's cancel. I'm going to use a different color so you can see it. The 2's cancel. Something in the numerator we can cancel with something in the denominator as long as it's multiplication, right? So what are you left with? You're left with 3x f of, if you could see this, I'm just going to rewrite it so that we are not confused. Minus 12 over 3 plus 4, right? So look here, if I can separate it and write it 3x over 3 minus 12 over 3 plus 4, which simplifies to what? This simplifies to 3x minus 12 over 2x minus 4 plus 4, which is just x. So what is f of f inverse of x? Sorry, f of f inverse of x. I said two f's together. It is x. So we got that. Now I want to do it backwards, right? You could have been able to see this. You could have factored the 3 here up there in this step also. In this step, if you didn't see it, then you just separate to f of, sorry, not f of, it's f inverse of, that was too big, f inverse of f of x. So again, what is my f of x? My f of x is, I'm going to rewrite it here underneath. It makes so much sense. I'm going to substitute my f of x with its function. It's 2 over 3x plus 4, right? And I'm going to go to my inverse function. Wherever I see x only here. So I'm going to substitute x with this whole thing. So what do I write? I would write 3, and then I'm going to write this whole thing, 2 over 3x plus 4, right? Be very careful here, and I'll tell you why. And the rest of it is minus 12 all over 2. Okay, you cannot cancel just the 3's with this, because 3 is, there is a plus term also. If it was the whole thing over 3, it would have been right. So let's rewrite it. 2 over 3x plus 4. So I'm going to actually distribute it. So if I distribute the 3, I get what? 6x over 3, which is same thing as 2x. And if I distribute the 3, I get plus 12 minus 12 over 2. Okay? Many people will actually make a mistake of doing this. And I'll show it to you. They'll cancel the 3's, and then they'll be like, oh, 2x plus 4. And if you had 2x plus 4, the 12's won't cancel. You'll have an additional 8, like, minus an extra negative 8. And you wouldn't know. And that would be that's a very common error. So I want you to eliminate that and be very careful with this. Especially whenever we're dealing with fractions, you have to be a little more careful. So anyways, the 12's cancel out. And 2x divided by 2 is what? The 2's cancel out, right? So what are you left with? So what is f inverse of f of x? It is also x. So did you verify it? Yes, you got that. So you can rewrite it here. F of f inverse of x is equal to f inverse of f of x, which is just x. If you wrote it that's fine, or just that's good, and put a check there. Okay, so try the